All right. So just by way of introduction, just a little bit about myself. So I am CEO and co-founder of AssetNote. Prior to that, I was running Spider Labs in the APAC region. Done a bunch of research. I've presented actually here in the past as well, mostly on mobile security. So if you're interested, check it out. And I do some community stuff in Australia.
My name is Sean. I'm the lead engineer and DevOps at AssetNote. I lecture extended web app security and software security assessment at UNSW Australia, ex-Microsoftie, an intern, and I'm a part-time bug bounty hunter, and the rest of the time I'm spending wasting it. So.
Cool. So just a little bit of an overview. With this talk, we wanted to talk a little bit more about the journey and the thinking, as well as some of the roadblocks, right? So a lot of these presentations, they're really kind of, here's the bug, and it makes it seem like you just opened your laptop, pointed it at the target, and then, bugs fly out. But that's not necessarily realistic. So we wanted to take you a little bit more on the journey. So, hopefully you can get a little bit more out of that. So we'll talk about how we approached attacking Zoom, the initial vector, finding the flaw, and then the exploitation of the vulnerability. We'll recap it at the end, and then we've got some key takeaways and some points that we want to make. So just to set the scene with this, so this was actually discovered at a bug bounty live event. For those who don't know, the big sort of bug bounty companies, HackerOne, BugCrowd, regularly put on these live hacking events. They're invite only. That's usually for one of their big customers. They bring in like the top sort of 50 or so hackers, and they usually give you sort of like a unique scope or extra rewards. And it's a sort of a one-day event. It's typically pretty competitive. Go Team Australia. But that's sort of the background here. So we were invited to an event actually here in Singapore earlier in the year. It was for a big Silicon Valley unicorn. Can't say who they were. We'd done events for them in the past in their bounty, and we know that their core infrastructure and applications are actually pretty locked down and well managed. But for this event, as is somewhat typical, they had a new acquisition in scope that wasn't in scope for their public bounty. But they also put in Zoom, which is not uncommon for these sorts of companies, particularly at these live events, to put in things like Zoom and other applications or systems that they rely on, that they see as kind of critical to their business. So that was in scope for this event. Spoiler alert, we did end up finding RCE and Zoom on macOS. We wanted to talk about it, but the disclosure kind of stuff was a little bit gray. We had an NDA with this big company, but not with Zoom. And we did get invited to their bounty afterwards, their private bounty, and they said, "Here, sign this NDA." And we're like, "No, thanks." But then this happened, right? So we weren't going to talk about it. We're planning on it, but it left. And this happened. I don't know if you guys saw this, but Jonathan, I'm not going to even try butcher his last name, found a bug, which would allow you to sort of remotely turn on people's webcams via Zoom. And then he's like, maybe an RCE. The answer to the maybe RCE is like, yes, definitely RCE. And it was kind of on the right path, but he didn't quite get there. So we had found it earlier. So this is that bug.
Right. So the first thing I'm going to go through is our initial approach when we come to these bounty events. Because obviously when you have 50 of like the best hackers in the world looking at one specific target, their main scope is going to be pretty saturated with really good talent, meaning that our likelihood of finding really good bugs in the core application is relatively unlikely. Our general approach as Team Australia is we usually go after satellite targets or probably less common targets at these core events. And this probably means the best hackers aren't looking at it, and there's probably more bugs that we can find. So this time, given the timing of the event and a whole bunch of other stuff, we didn't have a lot of time beforehand to actually look at the core platform or its satellite targets. Realistically, we only had about 2 or 3 days before the actual event to start hacking. So Shubs, our CTO, and myself were in Sydney Airport on our way to Singapore, and we're thinking to ourselves, what can we do on this 7 to 8 hour flight that would maximize our time? And realistically, with the unlikely outcome of getting internet on our flight, we decided to look at offline targets. So Shubs downloaded Zoom macOS, and I downloaded Zoom for Windows, given the only Windows user in our company. And we decided to have a look while on the flight. So the general approach that we take when we're looking at thick client applications on the desktop is, as opposed to web apps, we'll probably look at Hello? Oh, okay. Yeah, we'll probably be looking at the files that are unpacked and installed at first. So this will typically be things like config files, it'll be logs, it'll be secrets. And then what we're looking for is we're looking for opportunities of remote user controllable input. Now, what we mean by this is it's not things that like happen when you double click on the application, but it's things that you can interact with either from a browser or from other places in the application. So this is usually through like registered URL handlers, which is disclosed in like the info plist file in like a macOS package. And like for those who aren't familiar with macOS, that's like a metadata file that's in every single application that tells you about the application itself. And then when you go a bit deeper into diving into like looking at these client applications, we start reversing the binaries themselves. And here what we're looking for is opportunities as web exploit devs for things that we're familiar and comfortable with. So we're looking at web servers or open ports that these binaries open. We're looking for interesting function names or symbol names that might give us hints about what's happening. And we look for like obvious hard-coded secrets and hard-coded strings that disclose like some interesting stuff about it. Now, a smaller side that's not the subject of this talk, but it's also worthwhile thinking about the server side to these applications. And usually there's enterprise deployment solutions. So for example, you might have GitHub Enterprise or like Confluence Enterprise, and they're usually VMs that you can download and deploy into your own infrastructure. Now, it's pretty easy to root these VMs just like you root another VM, and then you can just dump the source code. So if you feel like auditing source, that's another opportunity. It may or may not be viable with Zoom. We initially looked at this, but didn't really explore it, and we're not going to look at it in this talk. But if you want to do something interesting, you got that. So looking into what we did for this event, Shubs noticed the Zoom application package had a sub package called Zoom Opener. And you can do this by like right clicking on the zoom.app, going to package contents, looking at the frameworks, and digging through the info plist file, he found they registered a URL handler called Zoom Opener. Now, as with Shubs, every time he comes across something, the first reaction is, there's got to be an RCE here. So he immediately sends it to me and asks me to reverse it. But before I dive into reversing the actual binary, I want to make two smaller sides. For those who aren't familiar, URL handlers are kind of like your HTTP or FTP handlers. They sort of like define a protocol and you can open them. But these allow you to like open specific applications. So you might have like a Microsoft Word handler or a Steam handler or like a Zoom Opener handler. And effectively what this allows you to do is deep link into application functionality. So this might open a specific page in your application or execute a specific function. So for those who are more familiar with mobile stuff, this is like iOS URL handlers or like Android exported activities. So other applications can trigger functionality in your app. The second aside I wanted to make was that the reason we found Zoom Opener particularly interesting was that there was a difference between the two operating systems. When I was looking at Zoom for Windows, there was no mention of Zoom Opener. The registered file handler wasn't even there. There was no registry entries, and it was only on macOS. So this immediately started triggering alarm bells in my head because I'm thinking, this is a specific handler that's not even on Windows. It's probably like a custom code path they developed specifically for macOS. So that makes this especially interesting. Now, some of our colleagues did look into, I think, the Linux version of Zoom. But we didn't dive too much since we spent most of our time on macOS. So if you want some of your own research, that's potentially an interesting target to go after. So now let's get to Zoom Opener. When I started reversing the binary, I discovered a web server spinning up on port 19421. And what this web server and what this URL handler was doing is a URL handler is effectively act as like a kind of proxy. It would wrap requests that you made to Zoom Opener and send them to the web server. And what was happening on this web server was there was a launch endpoint, which took like a whole bunch of different parameters, one of which was the domain parameter. So when we further dug through the binary itself, we discovered a function called download Zoom client for domain. And given that this application is called Zoom Opener, it probably opens Zoom. And if we can download a Zoom client from a domain we specify, it sounds like we can just open files that we specify what to download. So we got really excited at the potential for an RCE. But then we started digging some more and we realized that the reason why there are so many symbols and the names are so descriptive is because this is Objective-C. And Shubs and I are not exactly the best Objective-C reversers, right? We're like we're web security engineers. We like hack websites. So instead of wasting the next 3 hours on the flight bashing our head against the wall, we decided to wait till we got met up with Michael in Singapore. And he's had a whole bunch of experience reversing Objective-C because he's done a whole bunch of research into iOS. So we decided to wait, and then the next day we're all in Singapore. We're in my hotel room just hacking on some different targets, and Shubs hits up Mike with the good old, "Hey man, I've got something really interesting for you."
Cool. So this is where we dove into the logic flaw that's like the core of the bug. I was actually a few at the end of the day. But, myself, having not spent that much time like preparing for this event, and I was kind of really keen to sink my teeth into something that was in my wheelhouse, I'm like, sure, Shubs, let's take a look. So I fired up Zoom Opener and IDA and kind of got to work. So I was able to confirm that when the software update is triggered with the correct endpoint, that download Zoom client for domain, which is in the ZM Launcher Manager class, is called, and it is passing in as its argument the domains supplied to the launch endpoint. So it was basically as the guys had suspected. So let's keep digging. So just to go through this function, it first checks if there is a downloaded installer package already on the user's machine. And if that package is there, it will just proceed to install it by calling this install package function or install PKG function, which is also in the same class. So that's basically that code block, right? So it's just checking file exists at path, and it's got this package file path variable. If it does, it calls install package, right? Pretty straightforward. We thought initially this could potentially be RC in and of itself. If we could set up a chain where, it triggers our malicious package to be in the place, and like we trigger this install package. It's not really elegant, and we wanted to see if there was a way that we could trigger it in a more seamless way. So we kept digging. So the next sort of code path, right? If no package is downloaded already or exists at that path, it will trigger the download from the domain using the domain that we've specified as an argument to the launch endpoint. But it does some checks first, right? So it just checks on that supplied domain. So what it will do is it'll do this exact match. You can see that is equals to string function, which is just a framework function, a Mac framework function, which is checking like, is it equal? And so it's checking Zoom US, Zoom ziphour.com, zoom.gov.com, and zoom.com, and if the domain's an exact match. So we're like, man, it seems like it's validating the domain. We may have some issues here. But like maybe if we have a domain takeover, we could get RCE. So pass it over to Ruby, who's our R&D lead at AssetNote, and he's like a guru with subdomain takeover. So he started looking for that on other domains. And Jonathan actually mentioned this in his blog post, because he didn't quite get as far in terms of looking through the web server in detail. But while he was doing that, I kept looking. So I was continuing through it, and I noticed something strange. So if the code doesn't exactly match on those domains, it actually calls the following code. You can see here this has suffix, which is, again, just a framework method, and it returns a Boolean value whether the string ends with the specified suffix or not. So what this is actually doing is it's checking if the domain parameter ends with one of those, 4 domains, right? So Zoom, Gov, whatever, right? It's like on the end. If it's on the end of this string, then it's returning true, right? So that was pretty big, right? And so that was the core sort of logic flaw. And then once it's downloaded, the package is then installed by that same install package function. And all that function does is takes the package and passes it to installer, which is just, PKG files are just like the macOS, like BSD sort of package management sort of stuff. And the installer is just a way to install it. So putting it all together, we knew we could probably get RCE here. But we wanted to make sure. So I got Sean to set up a server using a domain I registered, AssetNote-hackzoom.com, and hooking to the runtime using script. I called that function directly and supplied the domain, as you can see here. It ends with .zoomus, so it's triggering that suffix check and it's passing that suffix check. And we got the hit and it worked, right? So just a little side note on script for those who don't know. It's got a ridiculous name. It's not Cycrypt, it's called pronounced script. And the premise is kind of even more ridiculous. It's sort of blending Objective-C and JavaScript. That's from their website. But it is a really great tool for interrogating and manipulating the runtime of Objective-C apps. So you can actually hook it into the process, is what I was doing here, or you can run sort of scripts as well. Scripts, great name. And so here's some sort of little tips and tricks. I've presented this before, but I just want to go over it just for those who weren't familiar. You can do some cool stuff with the runtime. You can print methods, all that kind of stuff. So triggering the download, back to Sean.
Yeah. So at this point, we're like pretty happy with ourselves. We're thinking, we can trigger a download from wherever we want. Like at this point, it should be trivial to trigger the RCE. And we're like, let's just head out for drinks. It's like 10 p.m. in Singapore. Surely there's some place with beers. They're really overpriced. And we think like the next day is going to be super easy, right? Or how wrong we were, right? When we started on the next morning of actually trying to trigger this RC, there was just hurdle after hurdle we had to hit. And like this web server that was running locally, it wasn't doing what we expected. Looking through the requests, it was making like weird requests to images, to other paths that like weren't finishing or weren't resolving properly. So we passed it over to Huey, who's our resident JavaScript guru, and he starts digging through it, right? And he's like reversing the JavaScript. And what he figures out is that all these requests to images that they're doing is returning an image with like specific dimensions. And the reason these dimensions existed was they mapped to specific status codes. And I guess like our interpretation was this was how they got around CORS, as in like cross-origin like resource sharing, because you can always load images. And what we found out was like these status codes represented what Zoom was doing in the background. So like some of the status codes were 1.1, which is a success, meant that Zoom successfully opened, or like 1.2, where you start like was an indication that it started a download, et cetera, et cetera, et cetera. And like we had to dig through the JavaScript a lot to find the specific mapping. And then we could slowly figure out what was happening when we're like hitting that localhost endpoint and seeing requests come in. So what we wanted to do was we wanted to trigger 1.2 specifically. And like this might seem easy, but it was surprisingly difficult. We had to play around with a lot of state on this like system because when you install Zoom, it drops a whole bunch of files everywhere. And like we couldn't exactly figure out what was happening. We had like 3 different Macs all installing and uninstalling Zoom. And then we figured out like what was actually going on. When Zoom was installed, it would drop a folder called .zoomus in your home directory, and it would copy Zoom opener into that directory. So when you ultimately deleted zoom.app, it wouldn't delete .zoomus. And the precondition effectively was you had to install Zoom once and then uninstall it. So zoom.app wouldn't exist, but in your home directory, zoomopener.app would exist. And the way macOS works with URL handlers is that as long as your .app exists somewhere on your disk, that URL handler will be registered for that specific application. So that means Zoom Opener will still be on your like operating system if you didn't uninstall it explicitly alongside zoom.app. And we're like, what the hell?
Yeah. And the interesting thing about this is like we're thinking, okay, like what is the sort of exploitation scenarios and how realistic is this, precondition? And I was thinking to like how I use this, right? So we do a lot of meetings day to day. There's Zoom, there's all these other different ones, WebEx, whatever. You install it for the meeting, and then they like often auto open when you start. It's like, I just delete them, right? That to me felt kind of common because I do that all the time. But then like, I guess the other scenario is, and I don't know how likely this is, but like maybe somebody releases a blog post that tells you that it can turn on your webcam and it goes viral and it gets a bunch of mainstream attention, and then everybody uninstalls Zoom, thus making them more vulnerable. I don't know if that's like a likely scenario.
Like what are the odds of that actually happening, right? Never.
But yeah.
All right, so now that we understood the preconditions we needed, assuming that occurred, the only thing we needed to do to trigger a download onto your computer was to hit this endpoint. And note that this endpoint had no authentication, it had no specific CSRF tokens, it had no required headers, and you could just hit this from any single browser, like any page on the internet, and a simple GET request would trigger a download onto your like local disk.
And all these other parameters as well, we were just copying and pasting them from another request for a valid Zoom meeting that we'd had with another company the day before. So it wasn't as if these were like critical for us to understand, but T was just like a time value, and USV. We couldn't even figure out what USV was. I think it's maybe to do with the version. Yeah. I don't know, but we just copied and pasted it basically.
Yeah. So the next question is, how do we set up our own download server so we serve a malicious payload? And you might be thinking that's super easy. Yeah, we wish, right? When we dug into the download Zoom client for domain function, Mike would notice that there was a class method for get download URL. So this is how it's constructing the specific URL we would pull out, it would start downloading files from. And it might be a bit hard to see, but this pretty much was a format string, not a bug, just a normal format string, where it would take our domain and put it into this URL. So when he tested it manually with script, it pretty much would mean that when we supply get download URL and give it our domain, it would just reconstruct this URL for us and try to pull the content from there. Now, obviously, when you're reconstructing your own malicious server, you want to try to emulate the actual server as close as possible. When we looked at Zoom US, we found that they were giving us a whole bunch of this metadata in this response. Now, let's dig a little bit into what this metadata has. First of all, at the front, it's got a checksum. And you may be thinking that's a bit problematic. But the thing is, we control the download server, so we can supply whatever checksum we want. That doesn't actually matter anymore. The real kicker is they didn't care about the checksum either. So we didn't even need to change this in the first place. They just ignore it anyway. The second thing is there's a URL here that says zoominstaller.package. So this is the final file that they're actually hitting to pull out our file. So it's like a little bit of interaction, but finally we get there. So we realize our target we want to pull out from is changing this URL on our server response. Now we have to actually try to set up this download server. And we encountered a few hurdles on it. We're hacking up a random Flask application, debug mode on, exposed to the internet. And we're just wondering why it wouldn't work. And we realized that even though there wasn't cert pinning explicitly, we still needed a valid TLS cert. So thank you, Let's Encrypt, for giving us the easiest TLS certs in 30 seconds. But after we started monitoring a bit more, a slight aside, this isn't a vuln, but this WJMF endpoint just starts sending a whole bunch of telemetry back to the mothership. It would send back installer logs, it would send back device information, it would send back other random bits and bobs from your computer. It's not super personally sensitive, but interesting that they have a whole bunch of telemetry alongside installing Zoom. So this server code might be a bit hard to read from there, but pretty much we just added all the endpoints that we observed that would be sent to us, and we try to copy it from the actual Zoom US server.
Yeah, it's cut off a little bit on the side in the screenshot. But yeah, we literally, the checksums even, there weren't even valid checksums for our package. We just copied and pasted it. So yeah, it's cut off a little bit. Then we'll talk about the exploit a bit more, but yeah.
Yeah.
Ah, cool. Over to me. So yeah, so now we were at this stage where we'd figured out that we could, supply a domain that we controlled. It was actually downloading something. We're able to respond with the right information to give it our malicious package. So the next step is let's craft this malicious package and go from there. So yeah, we weren't done yet, but one of the characteristics of these bug events is that they're time-bound, right? So it's one day. You can do some prep. They give you the scope a little bit ahead of time, but the actual hacking is one day. And for us, if we didn't get this bug done in that day, then it wouldn't be in scope. We wouldn't get any money for it, and whatever. So we're running down the clock at this point. So Huey and Sean were working on the server. I started working on the payload. So initially I set out to create a MacOS installer package that was our sort of malicious package. So with these packages, you can actually set pre and post install scripts, just bash scripts that run the code. So that was sort of my angle for RCE. We'd have it run this pre-install script and go from there. So the interesting thing when you do this with Zoom is when you trigger the update, you'll see it when we have the video of the POC at the end, but it shows up a little dialog box saying Zoom is downloading, right? And then it just sort of opens up once it's done. And so quite silent, and we wanted to do that. But when we were going through this method, one of the things that we noticed was it was actually throwing up the default macOS installer GUI for the installer process, the installer packages, where you click through, select your hard drive, click next and whatever. And that wasn't great. And I'm like, well, how come Zoom is not doing this, and we're triggering it? We tried it even if we just took our package and passed it straight to the installer binary, it was still doing it. We couldn't really figure out why, and because of the time constraints, we kind of moved on to other methods. But we found out after that the reason it works in Zoom the way that it does is basically they take the pre-install script, they get it to do everything that it needs to do, pass all the files, and then they actually kill the installer process so it doesn't show up the GUI. So that's how this thing works, and that was sort of after we released it. People were like, oh yeah, this is what it's about. I'm like, cool. So that technique would work, but we didn't actually use that technique in the end because we're all flustered, trying to get this done in time. So, time was running out, frustrations and our sort of drive and ambition to get this over the line. We really started trying a number of different techniques. We tinkered with command injection via the package name, right? So the package was being passed this installer function. It's just like calling out to like user sbin installer. And it's this, we tried all different kinds of command injection. We think this would work, but we couldn't get it quite to work in the time. And then Shubs actually suggested a technique that he'd used on other bug bounties, which is actually a cool little nifty technique. It's the sort of the .terminal trick, the terminal profile trick. So in Terminal app on macOS, you can create a terminal profile, which is just a .terminal file, and allows you to specify a startup command. So you can see here this run command value, and using this technique, you can run commands when you open this terminal profile, and it bypasses like a whole bunch of like permission checks and like any code signing restrictions, all that kind of stuff. So it's a pretty neat trick. Technique. So Shubs coded it up. So the way that you can create this, rather than like creating this this sort of plist XML sort of format, you can just go on macOS. You can go into the Terminal app, create a new profile, and set it, and then export it and download it. So this is what it is. Again, the screenshots kind of cut off our payload, but essentially all our payload's doing is opening our blog and opening calc, because of course that's what you do, and then just setting an alert box to display a message, basically. And also the stuff is just like standard stuff, like what's the font and all that kind of stuff. So, nothing really important there. It was just the command string is the main one. So we triggered the download and like success, it all worked, right? And we were able to submit the report. We had a working POC. Everyone was ready to go get beers and just be done with this bug. But I was writing up the report and I wasn't really satisfied, because if you remember how like the flow, or at least what we'd understood at that point, it was like passing it to this installer binary. And Shubs was like, oh, don't worry about it, man. It's probably just opening, the installer binary opens up different files and whatever. I'm like, no, it doesn't. That's not how it works, mate. So like I wasn't satisfied. These guys were ready to be done with it. So I'm like, that's cool. Like I'm going to dig into it a little bit more. So this terminal trick, it kind of only typically works when you're passing that to an open URL or an open file call. And there weren't any calls, as you noticed, to open file or open URL in the flow that we'd gone through so far. So I'm like, okay, cool. Back to IDA. Let's see if we can find this. So I started just doing like basic searches for open URL. Couldn't find anything. And so okay, let's take a step back and see where we go. I decided to revisit this install package function because I knew that it was going to that point and installing it. When I looked at it in more depth, I noticed that it called this install complete function, which is also in the ZM Launch Manager class, regardless of the outcome of the installer command. I'm not sure why it doesn't matter. It's probably because like they're not actually using the installer command, I guess. And it's just running its pre-installation script and killing it, and then install complete, right? And then I think that's when, and also in that function, that's when it triggers setting off all that telemetry that Sean was talking about earlier. But yeah, so that's what it was doing. And in that install complete function, I confirmed it was indeed passing the terminal file to this open file command. So the reason I didn't pick it up is because it's open file. Open file is actually deprecated, but if you're looking for instances where to do this, it's worth looking at this open file function as well. So you can see here, it's just taking package file path, which is the file path for our download, and passing it to open file. Cool. So I confirmed that this was the case using Frida. So you can see here I've just set up Frida Trace, which is like a tool that's sort of bundled in with Frida, which traces functions, as the name suggests. And so I just did NS Workspace, which is the class that the sort of framework class that open files in. And you can see here that it is actually triggering this .terminal file, like it is actually passing it. So another side note about Frida. Frida's like new hotness. I can't say enough good things about Frida. It's so much fun to use. It's just basically a dynamic instrumentation toolkit. This is from their website for reverse engineers and security researchers. It just injects Google's V8 engine into a process so you can execute JavaScript in the context of that process, and it's got a bunch of framework functionality around it. It's really great to write tools in, and even just using some of the package stuff. So it does have a bunch of stuff that they've already written, Frida CLI, Frida PS, all that kind of stuff. stuff. Free to CLI and free to trace are probably the most immediate useful tools when it comes to like, pen testing and bug hunting. But like a little pro tip for free to trace. So normally when you run free to trace, you won't get this nice string output here. You'll get, memory addresses and like hex values and all that kind of stuff. So it's not very human readable. But you can see here, it automatically sets up these handlers, which are just free to JavaScript files, right? And you can modify those. So, neat little trick is you go into those handlers where it's taking that argument, which would normally just give you like a memory address or whatever. You can go objc or objective-c.object, which is a free-to function, and basically it creates a JavaScript binding for that object. So then you can just use regular JavaScript to interact with that. So you can use something like toString, which is what I did there just to show that. That's actually also really useful for things like if you're tracing URL requests and stuff like that, like NSURL connection and whatnot, you can see the actual URLs that it's hitting in a more human readable output. So the final POC, this is putting it all together. So, you hit our malicious website. That's the dialog box. And then bam, you're in, right? And calc, because of course, and our blog where you can read other great research. Cool. So that's the POC, just pulling it all together. So basically what that's doing, again, just to recap the whole sort of chain, we're hitting that web server with the launch endpoint, passing our own domain, and on that domain we've got a web server that responds in the correct way that it needs to do to trigger a download. We're sending it to a path for our malicious file that it's downloading. It's downloading that and executing it as part of its install process. And that's sort of the complete sort of end-to-end POC. All right. Wow, we're ahead of time. It's great. Some key takeaways.
Yeah. So you may be thinking, how do we actually make this have a much bigger impact than just one or two people? And you might be thinking this might be a bit difficult to trigger, but the realistic scenario is, given there's no auth, there's no CSRF tokens, all you need is a GET request. So if you send someone an email with the same pixel image that MailChimp or other mail providers use to give you open or read receipts, if you use the same idea, you can trigger a web request the same way. And that is all you need to trigger an RCE. Alternatively, if you have an XSS or you have malicious JavaScript on any of the sites you host, people who visit your blog or visit your page instantly get popped. Now, if you want to have a much bigger impact, say you want to target a whole company, what you could do is you could start sending targeted ads to this company. And if you just embed some embedded JavaScript or an image into these targeted ads, you can start targeting an entire company's worth of people and have some really large impact mass exploitation style bugs. Assuming, of course, they had Zoom installed and uninstalled, but
Yeah. Cool. So, what were some of the responses and the fixes? So Jonathan publicly disclosed the bug, and people started looking into the potential RCE that we had found earlier, and then several fixes have now been pushed from both Zoom and Apple. The Apple's one is quite interesting. It basically treated the Zoom opener in that sort of zoom.us as a .zoom.us folder as malware as part of their XProtect system, so it just deletes it. I just found that funny that it's treating it as malware. Because the reason we found it funny is early on we couldn't figure out why they had this Zoom opener, right? And it was kind of for me, it's you don't have Zoom installed, you just download it again and then trigger your meeting again or whatever. We couldn't really figure out why it was, and we had an internal nickname for Zoom opener called Zoom Dropper. So that's why I just found it neat that Apple sort of basically treated it as malware. None of these techniques should work in the latest versions, but obviously we recommend you apply all the patches and reduce your exposure. That's not to say there aren't other bugs. I mean, this was pretty glaring and bad, so who knows what else is out there, but definitely always patch your stuff, right? The other interesting thing that came out of all of this is Zoom app actually white labels their Zoom client to a number of different companies, mostly telcos and stuff like that, and they were also vulnerable. It was all had the same code, and it was all different different names, but it was all the same stuff. And Karen Lyons actually has a great guide on his GitHub where he went through all of it and, mapped it all out and, collated all these ones so you can delete them. Apple eventually went through and added those again to their system. So that's all good, but that was just another interesting side note as well. So the other point that I kind of want to make is collaboration is key. There's, I guess, still that, stereotype or whatever of the lone hacker, like hacking away. For us, this was like a team effort. It was a lot of fun. And, if any single one of us, were just focusing on this ourselves, we probably would have given up and gone on to other things, right? Giving up at reversing Objective-C, I definitely would have given up at JavaScript, right? I would have had an aneurysm trying to do that stuff. So I definitely gave up there. But all the pieces together sort of, came together and it was a lot of fun. It was the only bug that we ended up submitting for this event, which is kind of unusual. We tend to submit quite a few bugs. But it was the most fun that I've had, at least at any of these events. So it was good. So yeah, I strongly recommend, working together with a team. Whether it's pen testing, bug hunting, CTF, whatever, you'll learn a lot from each other. You've got complementary skill sets. You'll be able to achieve more. Solo hacking has its moments, but, the experience that you get as a collaborative team is a lot better.
I think the one thing we found is, especially with these events where we all get together, it's a lot easier to keep morale up if you have like 4 people in a room and a pack of Red Bull.
Yeah.
It's a bit difficult if everyone's in their own homes, because it's really easy to say someone grabs lunch and it's really quiet for 2 hours. Yeah. And then morale drops a little bit.
Yeah. So, I made a note here about how the Australian InfoSec community is pretty friendly and welcoming. In my previous role at Spider Labs, I had a lot of involvement in Singapore as well. And I can say that that's also true for Singapore. Got mad lads like Keith down the front here. He's really solid. You should follow his stuff. He's really good. And it's a really tight knit kind of community here as well. So, definitely reach out to your peers and, have some fun hacking together. And then just the other thing we wanted to recap was some of the tools and techniques, right? We used IDA, but Hopper or Ghidra, thanks NSA, are really great alternatives, and they're cheaper, and Ghidra is free. Frida and Script, as I said, can't say enough good things about Frida. It's so much fun to use. Script is great as well. It's not as developed as much. It's not really designed for this sort of stuff. It was never designed to be a security kind of tool, even though you can use it for that sort of stuff. But yeah, Frida's great. Terminal profile trick is really handy. Shubs did on one of his previous bounties, but he found out about it from other people finding these sorts of bugs in other bounty programs. So, probably a cool thing to look at if you're interested in, having a play around.
With these applications that were testing server-side stuff, being able to just quickly hack up a script in Python makes it also super easy. And if you're worried about SSL certs and domains, Let's Encrypt makes your life so much easier with that. So if you have any amount of coding skills, Python's super easy to get set up with this stuff.
Cool. And yeah, the final point, beer. But the key to this technique is not too much, not too little. So, just to be clear, drink in moderation, guys. Cool. And that's the end of our talk. So we can take questions.
Okay, does this work? Okay. That was really fast. So thank you so much for that really interesting talk. I just wanted to throw it open to the floor first before I go to the questions on Slido. Anybody have any questions? Remember, there are prizes available. Awesome purple T-shirts, right? From Asset Note.
Yeah, Asset Note swag, mate. Get on it.
Really nice swag. So anybody have any questions? Yes, sir. Do you have an extra one?
Actually, I already posted in there. I want to ask, is this the so-called drive-by download? So
No. So you're referring to the drive-by download techniques that were somewhat common in the past on macOS, where it would automatically execute certain files that were downloaded from Safari. This isn't that. This is actually using Zoom to do that. I think for the most part, anything that's really sensitive to automatically execute now in macOS, it gives you a little warning to say, hey, this is download from the internet. Are you sure you still want to open it? And then if it's from a developer that's not recognized, so it's not one of their notarized apps, or it's not through the apps, through the developer sign sort of thing. It'll even say, you even have to go into the security settings to be like, hey, yes, I'm okay to open this. So those sorts of attacks are less common now. And this is kind of different. This is more just exploiting the inherent functionality that was in this Zoom opener thing.
So this one is only targeted on the Zoom, is it?
Yeah, Zoom and Zoom on macOS specifically, as Sean mentioned earlier. This functionality wasn't present on Windows at the time. We did have a few folks, one of the guys from Team Sweden, big up to those guys, they were looking at the Linux client after we told them about this, and there seemed to be some sort of similar functionality there, but neither of us really explored that. So if you want to go, hack on something, that might be a good thing to look at. But yeah, it was just on macOS specifically. Yeah.
So you said I have logged in using the Chrome browser, which remembers my sign in order. Then I did not turn off the ad popper. So it will automatically download the Zoom.
Yeah, so this is nothing to do with the browser. So this is completely outside the browser. So this is that Zoom opener web server, Zoom opener binary, which has the web server that's interacting with it. So we hit that web server. This is a web server that's running on localhost at that port, it triggers this code functionality which automatically downloads it. So it's nothing to do with the browser. So if you got a Zoom link, so like when we're exploiting this, basically that request that we had up, I'll get to it. This one, right? That's what we're hitting, right? But if you get like a normal link, like that actually goes to Zoom, like a normal meeting link, right? It's not going to be vulnerable. It's not even hitting that same thing. It's completely separate.
So the normal Zoom that I'm using is safe lah.
Yeah.
Okay.
Yeah. Well, I don't know about any other bugs. Can't speak to that, but this has all been fixed. This whole functionality, the whole web server, everything doesn't exist anymore in Zoom. Yeah. Yeah. No, you're okay. Yeah.
Thanks for that question. I also had a little bit of a sleepless night when, so that was the first question I asked Michael when I saw him this morning. Is it all the Zooms or, and so, yeah, put me to rest. Any other questions? Yes, ma'am.
Do you know why the Zoom opener is not present in the Windows version?
Yeah, so this was something that we couldn't really figure out. Again, as I said, we couldn't really figure out why this whole thing was happening. And there was some commentary once this all came out and all the blog posts came out and whatever. My gut feel is this was in there to get around certain things that were added in macOS. So when you trigger something through like a URL handler now, it'll actually come up with a little alert box to say, once this app wants to open Zoom Opener, do you want to allow, right? And so it's a click. So I'm thinking that this was a way with this whole like web server and all that kind of stuff. This was a way to get around having to have users click allow. Right. That was the sort of prevailing theory. And I believe Windows. Yeah. I'm going to refer to our resident Windows expert at Asset. But yeah, I believe Windows doesn't operate in the same way.
Yeah. I think that's our main theory, but I think now with the current behavior, yes, they preserve the idea of security over font, like very easy user design and user experience. I don't know. There's probably other reasons, but we didn't really explore it in that period of time.
Thank you. Any more questions? Yes. Another young lady at the back. Is it?
Hi. Yep.
Hello.
Hi. There we go.
Hi. So Apple puts their patch from their side. What if we download the downgraded version of Zoom? So we can still trigger this exploit on the degraded version?
There might be some scenarios, I guess, where you can, but generally speaking, as I understand it, and I don't know too much about XProtect and how that all works, but it's basically like AV, where they add signatures and like if something's there, it deletes it or quarantines it or whatever. My understanding is they added Zoom opener is specifically the one that's left in your home directory, added that to that system so that if it is ever there, left after you uninstall an old version or something like that, it actually automatically deletes it and quarantines it. So I think it's okay, but don't quote me on it because I'm not 100% sure how it works, but that's my understanding of that kind of side of the fix. But, as well, going forward, more new versions of Zoom, they don't even use this anymore. It's gone. So even if you have Zoom installed, you uninstall it, it's not leaving anything like that behind. So you should definitely upgrade. But my understanding is even on an older version, it should be all right, but I guess, I don't know enough to say that, there might not be scenarios where you can downgrade it and do it, but it's probably at that point, actually exploiting that is probably unlikely, I guess, but yeah.
Thanks, Michael. And yes, one question in the front, and then after that, I'm just gonna hop over to the question from Slido. In the front on the red shirt, yes.
The bug is not existed anymore in the new version of Zoom, right?
Yeah.
What kind of modification they use?
They just got, as far as I know, they got rid of the Zoom opener, that whole functionality, though, the web server and all that. Well, I don't know about the whole functionality, but at least the web server component with the vulnerable stuff. But my understanding is that this Zoom opener doesn't exist anymore, basically. Yeah.
Okay, I'm gonna, before I get back to the audience again, I'm just gonna read off the top voted question. Oh, there are two top voted, so I'll read one first and then we can. Mm-hmm. In your opinion, are there any prerequisite or good to have certifications or courses that can help me in a career of finding remote code executions, RCEs?
Yeah, so this is an interesting question. Look, I don't think there's any prerequisites other than curiosity and a will to do it, right? Because it can be, one of the things we wanted to highlight again with this talk was it wasn't just a walk in the park, right? And we did this really quickly and whatever, but it wasn't something that just happened, right? And particularly when you're diving into binary exploitation, this wasn't even that low level, right? And that difficult. When you're really diving into it, you need to just have that kind of will and determination to keep going. And I think that's just general for hacking. Hacking in general. So I don't know. I think that's probably the only prerequisite is the right mindset in terms of technical skills, qualifications, so long as you've got that will, you'll learn it, right? So I wouldn't say that there's any kind of certifications or courses. In terms of a career, right? I would definitely say put yourself out there, right? When you're learning this stuff, write a blog or whatever. And a lot of people get caught up in the idea of it has to be novel, it has to be unique, it has to be great research or whatever. Forget about that, right? Just write, document your learning journey, share it with others, go to meetups here, and, present it to others. And, that shows potential employers that you can actually do this stuff and that you are learning and you've got the right mindset and skills. And I think that helps in a lot of ways, more so than certifications or courses.
I think the one thing that helped me most when I was starting out is instead of looking for certifications, I just did a lot of CTFs. Because I know Hack in the Box runs their own CTF that they have finalists for that come here. And I think those are really good entry point because they give you a whole wide range of challenges, from the absolute beginner to things that are just malicious and intentionally trolling the participants. So I strongly would recommend participating in CTFs. There's usually one every week internationally, and you have your own leisure time, or you can get some friends together with some pizzas to do it as well. Cool.
Great, thanks. And I know I said I'd go back to the floor, but I really like this question now that's come up on Slido, the top one. Yeah. Could this be a backdoor put in Zoom on purpose?
Look, I'm not an overly paranoid person. I'm going to say no, right? One of the things that we learn now, so we have a platform that we develop. So we've gone from being security guys to being developers. And if you're doing anything on scale, Zoom has 45 million users or something ridiculous like that. It's hard, right? And, people make mistakes and that's where a lot of the stuff comes from. It's just natural, right? Yeah. I didn't get the sense that any of this was malicious because it was kind of so obvious. Yeah. But that's my opinion. I don't know if you have a different opinion.
I think the other thing to consider is as app designers, not so much developers, they're so focused on having a seamless user experience. Yeah. And the idea of having, I want to join a meeting. So you want me to click a link and then click another button and then some other buttons is because like in designer land, that's like so many barriers and funnels that it's too difficult to convert someone. So they really wanted to make it as easy as possible for someone who might have had Zoom before to just open up another meeting.
Yeah.
And like I can see how this idea comes through that obviously has a few other security vulnerabilities on the way.
Yeah, I definitely felt that. It was more like driven by functional and design requirements more so than anything malicious. Yeah.
Okay, thanks, Mike and Sean. Any more questions from the floor? It's a pity this person who posted that question earlier didn't give his name or her name, otherwise you would have worn a nice t-shirt.
Yeah.
Okay, but any more questions from the floor? Yes, gentleman at the back over there.
Oh,
Hi.
okay. So, user interaction is quite an important measure in terms of measuring the severity of the bugs. So, in your case, for the Zoom openers, I think it doesn't require any user interactions. But in general, for those URI handlers, when you open it in the browsers, usually you pop up the alert box, right?
Yeah.
So will you try to use some ways to bypass this box to increase the impact?
Yeah, where we ended up was zero interaction in the end as potential. But when we started out, we were actually using the Zoom opener handler rather than hitting localhost directly.
Yeah.
And that triggered, that's sort of what I was saying to the lady earlier, that, Zoom opener wants you to open, this website wants you to open Zoom opener. And, yes, that's an extra click. But when you think of the scenario, I think it's a very likely exploitation scenario where it's like, hey, join my Zoom meeting. And then this wants to download something called Zoom Opener. It's probably likely to get clicked on. Yeah. I think, yes, it does go to the severity. I think it just really depends on what the user interaction is and how you can craft a scenario around that. And, the likelihood that people click on it is probably generally pretty high.
Like the realistic expectation is if you get a meeting invite and you go to a site that says, do you want to open your Zoom meeting? Like your initial expectation is, yes, I want to get into this meeting. So even if there are pop-ups, regardless of the user experience, they're going to click through anyway. So even if we had to go through Zoom Opener, I think the likelihood of being people actually use it, like getting hit by the exploit is still pretty high. Yeah.
Okay, thank you. Any more questions before I go to Slido again? No? Okay, the next one is how much time did you spend in total in researching and realizing this exploit?
Yeah, so it was like maybe 2.5 days. So if you count the time on the flight, that probably brings it up to 2.5 days. So it was just so the event was on the Friday. We were flying up on the Wednesday. And then we spent, Thursday, not necessarily all day Thursday because we got up pretty late, because we'd been out the night before. And then all day at the event Friday.
But this is like across 4 people.
Yes.
So
yeah, it is us working together. It wasn't a solo effort.
Yeah.
Okay, thanks. Any more questions from the floor? If not,
I'm just reading the next one here.
Yeah.
Do you always spend your free hours in the airport to hack? And the answer is yes. Especially
the
Shubs.
last
Like
one, okay.
we'll land in a country and like the very first thing when we get into the taxi is like opening his laptop and start hacking.
Yeah.
So yeah, that's very common.
Okay. What about the next one? What advice would you give people entering this field?
Yeah, just like very, similar advice to what I was saying before. Try it and get out there and do it. Like one of the great things now is like, particularly with bounties, so you can hack on real world targets like this, and get away with it. It's fine. And you could potentially even get paid for it, right? So, that's a really great, thing that exists now. There's a lot more learning resources as well. But yeah, I think really just having that mindset and the will to do it. It's not necessarily hard, but it's not necessarily something where it's just like you do a course and you're good. Right? Or you go do some training somewhere or you get a certification and that's it. Like I really feel like if you've got the mindset, that's a real differentiator for people and that sort of will. It's not necessarily you need to be like this gifted hacker innately. It's just kind of like the will to keep trying things and when you hit a roadblock, try something different and talk to other people about it and keep moving forward.
Yeah. Right. Thank you.
We still have about 5 more minutes so we can continue answering the question.
Sure.
Is anyone from no? I thought we had till 11.
Questions up here actually.
Oh, change over. Okay, so maybe one last question. Okay, one last question from the audience. No? All right, then one last question from Slido, and then you have to.
Yeah, I'm going to.
Choose
I
your
can do.
favorite.
I can do I can do these really quickly. So the first one, do you feel static code analysis tools would have helped? Probably not for this one, just because of how they work. 2, how long has this bug existed in Zoom before it was patched? Probably, well, at least from when we found it to when it actually got patched, it was a matter of like 4 months, 5 months thereabouts. And how did Zoom roll out the patches? Generally in a pretty poor way. They responded, but then they came around and they handled it okay. Are the beers in Singapore the most expensive during your travels in the world? I've traveled a lot, and the answer is yes. So
I could have answered that. Okay, so we want to give the prizes out now. We had the most, the one with the highest votes, but unfortunately we don't know who is the one who posed that question. So sorry, no gift for you. But out of the other questions that you got, who do you think should get your coveted purple t-shirt?
I'm going to give it to this lady down the front here. So second row.
Oh, well done.
That was good.
Thank you.
Okay.